You are given an integer array nums. You are initially positioned at the array's first index, and each element in the array represents your maximum jump length at that position. Return true if you can reach the last index, or false otherwise. So, for example, in this example one, we have nums array starting with 2. So from 2 we can go on to, we can have 2. Since the value is 2, we can go to 2 places index. So this is the maximum so far. So here 3, we can go 3 places index. So 1, 2, 3, and boom, and that's why it's true. So we can reach the maximum value. And here it's false. So because we have 3 here plus 3, which regards to this one maximum, and this one 2 regards to this one maximum, and this one regards to this maximum. And this one, since it's 0, it can't come up to here, so we get a false. And I'll use this to demonstrate with our greedy algorithm. So this is a greedy algorithm problem. So let's name a variable furthest and give it 0 to initialize. Initialize initialize our furthest distance so far. No, thus far. So now let's move on to our loop for I in the range of the len of nums. So if I is greater than our furthest, return false. So in this example, since we're going to start from here, this will be an index of 0 used on range. It will not get to this yet. So here, once we get to this one, it will be false, since it's going to be greater than our furthest so far. So we're going to update our furthest. Let's call it furthest distance index distance. We copy and paste this for the other variables. Furthest index distance. Boom. And equals to the maximum of furthest, or the nums I value plus its index plus I. So now let's check. So for if if furthest distance, let me copy and paste, is greater than or equals to our len of nums minus 1, which will be more accurate of our index values that we're using, since we're using minus 1, since we're going to start from 0. So return true. Let's move on to return false if we don't have a true statement here. So furthest distance, oops, this one should be updated too. So we're going to start, for example, here we're starting with 0, so this is greater than the furthest. It's not greater than the furthest distance, so we don't have a false yet. So we check to see which one is the maximum number, and then check um, its value. um, so its value plus 1, so that would be so plus 1 1 2, so that would be the next index. So here it will be so since we start from 3, it will be 3, index would be 0 1 2 3, so this is the maximum now. No, 3 3, so since we have both numbers are 3, the maximum is 3 here. So the first distance 3 is not doesn't meet this condition yet, so it's not true. So we're going to move on to the next value here. 2 is not greater than our furthest distance, which is where the index 1 is not greater than our furthest distance, which is not, so it's not false yet, so we check 2 plus, no, so 1 plus 1 2, so this one is also 3, so it's still our furthest distance is 3, so it doesn't meet this condition yet. So we move on to the next value, and this one is 3 3, so this one is also index of 0 1 2, so 2 is the index. So our furthest distance is index of 3 here also, so maximum value is still 3, so it doesn't meet this condition yet, so we move on to the next value. This one is 0, so and the index is 3 here, also 3, so we move on to 1 2 3, so it doesn't meet this yet, and then 3 3, no so index of 3 is not greater than our index so far. No, our index of 3 is not greater than our index of our first distance so far. So we move on to our first distance, which is since 0 plus I is still 3, our nums I plus our index is still 3, maximum is this isn't met yet, so we move on to the next one, the last value, and this one is at an index of 4 0 1 2 3 4. So this one is met, so that's how we get 4 here, boom, and that's why this is the solution. This one is false and this one is true, and the rest run it and to see if it works. And it's been accepted. Let's submit it to see if it will pass all cases, and it's been able to pass all cases, and that's it for this problem.